In the previous section, we have looked at statement variables, P, Q, R, etc., and the 5 logical symbols, not, and, or, implication, and biconditional. We also saw how to build up more complicated expressions, statement forms, using the 5 logical symbols. We also looked at how to evaluate the truth values of statement forms using truth tables, and how to construct arguments using inference rules. This study of statements is called statement calculus. Okay, it's also called propositional calculus. Propositional calculus, or propositional logic. In this section, we'll look at what's called predicate calculus. Okay, predicate calculus. It deals with predicate symbols and quantifier symbols, in addition to the logical symbols. Consider the statement, John is tall. We can replace John with the variable x to get x is tall. And let P stand for is tall. Then we can write x is tall in symbols as P of x. Okay, P is called a predicate symbol. And x is called a variable. Okay. In predicate calculus, we have a set of predicate symbols, P, Q, R, etc., and a set of variables, X, Y, Z, etc. We can think of P of x as a function of x where we can plug in different values for x. For example, if we let J stand for John, okay, let J stand for John, then P of J, that means John is tall. Okay, if we let S stand for Sue, then P of S, that means Sue is tall. The symbols J and S are called constant symbols. Okay, the symbols J and S, those are constant symbols. And we can think of them as names for objects. Okay, in predicate calculus, we have a set of constant symbols, A, B, C, etc. A predicate symbol could stand for a function of more than one variable. For example, consider the statement, John is taller than Sue. If we replace John with the variable x and Sue with the variable y, we get x is taller than y. Let Q stand for is taller than. Then we can write x is taller than y in symbols as Q of xy. Okay, so Q of JS, that means John is taller than Sue. Okay, since J stands for John and S stands for Sue. Okay, a sentence containing a finite number of variables that becomes a statement after substituting values for the variables is called a propositional function, or simply predicate. For example, P of x and Q of xy those are predicates. Okay. The set of objects that we can substitute in for a variable x is called the domain of x. In the context of our example, P of x here, John and Sue are in the domain of x. Okay, the constant symbols J and S, those symbols J and S, they name objects in the domain of x. Okay, so J stands for John and S stands for Sue. Okay, now we can stipulate that the domain of x is the set of all people. Further, let's assume that John is tall and Sue is short. Then P of J is true and P of S is false. The truth set of P of x is the set of all objects in the domain of x that make P of x true. Okay, so John would lie in the truth set of x. The truth set of P of x, while Sue would not.